interface. So in this video, I will be explaining you about the internal implementation of HashMap as well as the different varieties of interview question that has been asked to me with respect to hashcode and equals overridden case. There is like around 14 to 15 different cases, like in unique way it will be like 10 to 12 cases, but those 10 to 12 different hashcode and equals overridden cases are there, which is very much useful for us to understand, because based upon that there can be different set of questions that can be framed. HashMap is a very important data structure for you guys. It's not a part of collection interface, it's a part of collection framework. Why it is not being part of collection interface, that all things also we need to understand. Put operation or the process of adding the data into that particular map is different, and fetching the data, the process is entirely different. Okay, so HashMap internally make use of HashMap. Okay, so we should first understand HashMap to understand HashSet. Okay, so let's dive deep into it to understand it much better. So let me share my screen. So watch this video till the end, because in this video I will be explaining about the overridden hashcode and equals questions that can be asked in the interview, which has asked to me in the interview. Those are very good questions. Okay, so stay with me till the end to understand it better. So I hope you can see my screen now. So important HashMap interview questions that has been asked to me. I've given around 20 plus interviews in past 2 months, so I can help you better to understand like what all varieties of questions that has asked to me in the interview, so that you also get the better understanding and clarity of it. Okay. So first of all, what are the different methods of HashMap present, and especially the last one, the entry set. This was asked to me. So what exactly entry set contains? So entry set contains data of map.entry. Okay, so it contains the data of key value pair, a map, a set of key value pair map. Okay, why we are doing entry set? Because streams, if you are doing, or if you are doing any operation on map, then directly you can't work upon map. You need to convert it into a set, and then only you can work upon it, right? So it is very much useful in doing the iteration process, or you want to do the stream operation. In that scenario, converting it into an entry set is helpful. Okay, and there are different kinds of method names are available with us. Like put method is there, which will accept key and value pair. Okay, where key is the, where key can be anything, it should be immutable, it should be unique. Okay, and value is anything you can have, there is no restrictions on it. Okay, then void type, put all if you take. Okay, if you consider put all method, then it will have all the maps present within this map. Okay, there will be like a list of maps, so a lot of maps will be put across one particular map. Okay, so that is put all. Then get, you are trying to get the data based upon the key. Okay, so you are passing the get of key and you are getting the value part of it, that is get. Remove means you are trying to remove that key. Contents key, it will check whether there is any object present in the key part or not. It will basically check. Contents value, it will check the value, it's present or not. Is empty, it will check for empty scenario. Size, it will check size. Clear, it will remove the things. Okay, it will clear the map. Key set, it will print me the set of all the keys. Values, it will print me all the values present in the map. Okay, entry set I already told you. So in these things, what all the return types are present, that also should be kept in mind. So put, it is object. Okay, so these things, if you are keep on practicing, you will get an idea of it, like what all things are there. Contains key will check whether the data is already contained or not in the key. So these things you should go through it once. Okay, we'll get the clarity. Then comes hashcode and equals contract. So before coming into it, I wanted to tell you that there is a proper implementation provided for HashMap. Okay, so you should first understand hash table. What's the difference between hash table, HashMap, collect, synchronized HashMap, concurrent HashMap? These things are also asked. There are various varieties of HashMap, like identity HashMap, weak HashMap, enum HashMap. I've created a separate video on HashMap. There you will get to know what all separate varieties of maps are present. I will give you in the I button or in the description box below also. I will be adding that video link, so that you will get to know like what all different varieties of maps are present. Okay, so just go through that, you will get an idea of that. Let's come to the hashcode and equals contract. What is this hashcode and equals contract? So hashcode and equals contract tells us, like, if the two objects have the same hashcode, okay, then that doesn't guarantee that two objects are equal. Okay, but if two objects are equal, then that guarantees that the hashcode will be same. So this is very important and should be there in the mind always. If Hashcode is same, that doesn't guarantee that two objects are equal, but vice versa is possible. So that is important. Next comes this map.put. I already told you. So how the internal implementation works in put operation, that we have to understand. So when you are trying to put, then what all things comes? Let me show you now. So this is the entire thing that happens internally when you are trying to put the data. So first of all, what happens here? So if you closely observe here, first map.put is happening. You are trying to put the data. So how put operation works? First of all, hash code will be calculated. Okay, so hash code of the key will be calculated. So there will be like a 16-bit hash code will be generated through the hashing function which it goes to. Okay, and then it does the AND operation with the length -1 of the hash code, or you can do modulus with the size of the hash map. That also you can do. So whatever the result will be coming, that will lie in the index range of 0 to 15. Okay, the size of the hash map is 16, so it will lie from 0 to 15. Any number can come. So that will be the index point. So that index will be the actual location or the actual bucket where that key value pair will go. Okay, that is with respect to put. It will first check the hash code value. If hash code value is find it out, then it will do modulus with the size of the hash map. Then it will find the index value. After finding the index where it will lie, the bucket, then it will check for value part. Before putting the value part, it will check like where exactly the value should be kept. That also we need to understand, right? So it will search for the existing key. So there can be multiple keys with the same value, right? So once that key is found, it will be going to that index. Okay, and in that index, it will be checking, is there any other key value pair already present where hashcode and equals becomes true? Okay, hashcode and equals are satisfied. Then if it is not present, then it will create a new node. Okay, so there it will be stored data in the form of hash map. Okay, so there will be multiple buckets available here. There will be multiple buckets available here. Okay, so you can think of it like 0, 1, 2 up to 15. Okay, and then it will lie to this particular bucket, let's suppose. So initially there is no node available in this particular bucket. Let's suppose I'm doing the modulus of this hash code. Okay, modulus with size of this hash code. So it is coming as 1. So it will go to this particular index. So here there will be multiple partition. First partition will be hash code. Second partition will be key, then value, and then next node address. So next node's address will be initially null. So like that, data will be stored over here. Okay, so like that. So if another key comes with same hash code, then what will happen? It will point to the same bucket, because the bucket location is the index point where the data is being put when hash code remains the same. But there will be the equality condition check is also there. The equality condition will be checking whether that key is already same or not. So if key is unique but hash code is same, okay, so that will, what will happen in that scenario? Hash code is same. Okay, so multiple keys can have same hash code. So it will come here and with equals method it will check whether that key is already present or not. So key is one key is already present, another key you are trying to insert, then it will be added in the form of linked list. So multiple nodes will be connected. So these two nodes will be connected in the form of linked list. I hope you got the clarity on this. So this is called as hash collision. If multiple keys can have the same hash code. So in that scenario, it will check. The key will be checking the existing key. If key is already present, then it will be added to the linked list by replacing the existing equal node. Okay, so whatever node will be present, it will be added in the form of linked list. Okay, and then if key is not present, okay, so if key is already present, then it will be added to the linked list. It will replace the existing node, or else if key is not present, it will be added to the linked list as a next. Okay, so it will just check whether there is an existing key or not. Whatever key is coming over here, no, it will check with the existing key. So if key is same, like same key you are trying to put it again, then it will replace the existing node. Okay, and then if it is not present, if it is a new key with the same hash code, it will add a new node to the existing node, and then it will form a linked list. Okay, so if hash collision is not occurring, then it will simply add to the linked list as a first node. Just like it will go to another bucket and data will be added as a first node. Okay, so this is the entire process basically. So now you got to know the importance of equals method. So first Hashcode method is calculated to find the bucket point where exactly the data will be storing, the key will be storing. Okay. And then there will be equals method also will be there, which will check the existing key. Whatever the key existing key is there, it will check with what value of key is coming. So if both the keys are matching, it will replace the existing node. And if both keys are different, it will add multiple nodes in the form of linked list. It's a simple implementation. So in this also, there can be multiple varieties of Hashcode and equals based scenarios. So that we'll be understanding now. So now different scenarios for Hashcode and equals will be coming. So this is very important for interview perspective. So stay tuned till the end so that you don't miss this part. This is very important part. First comes when both Hashcode and equals are overridden with correct logic. What will happen? It's a best case scenario. Okay, Hashcode and equals method are overridden properly, and you have written proper logic to implement a Hashcode like objects.hash you are writing, and you are passing all the fields over there. It will work fine. There will be no issue. Okay, and you are overriding equals method as well. So those equals method are providing the same Hashcode. Okay, so it will be going to the same bucket. Okay, so if the Hashcode and equals method are working perfectly fine, then it will give proper answer. Okay, so there cannot be any possibility of much of hash collision. There can be a chance that hash collision can occur, but it will be the lesser side. Okay, because Hashcode and equals are overridden with a correct logic. Okay, so the HashMap will work correctly, meaning it will store and retrieve values as expected. So if two test objects are considered equal according to equals method, they will produce the same hash code. Okay, so if two objects are equal with respect to this equals method logic, then they will produce the same hash code. That is a hash code and equals contract. Okay, so this ensures that they will be stored in the same bucket and the map will be able to correctly find the value associated with that. So I hope you got this clarity on this. Next comes if both Hashcode and equals are not overwritten, then what will happen? If both Hashcode and equals are not overwritten, then it will give the default implementation of object class Hashcode and equals method. Okay, so object class has a lot of methods present within this, like Hashcode, equals, wait, then sleep. Okay, wait with no argument. Okay, then finally, then get class. There are a lot of methods are present over there. So Hashcode and equals are one of them. So that object class methods will be overridden if you are not overriding Hashcode and equals method explicitly. Okay. So this equals method will check for reference equality. Okay. And the default Hashcode method provides distinct integer for different objects. So it will not guarantee the uniqueness because you are not providing the condition based upon which it will uniquely identify those objects. So let's suppose I am passing two employee objects with ID 1, name Dev, age 20, and salary 30,000. So same values, if I am trying to add it again, all values are same, everything are same, employee objects are same. But two employee objects are there, employee E1 equal to this value, whatever I told, employee E2 equal to the same value. Then what will happen in that scenario? It will point to the same bucket, but Hashcode internally, if you see logically, it should point to the same bucket, right? You should not add the same data again. If you add the same thing in set, then if you are overriding Hashcode and equals method properly, then what will happen? Those two objects will be considered same. But here, Hashcode and equals method are not overridden. Then what will happen? Both will go to different bucket. The size of the hash map will be 2, not 1. Because Hashcode is not overridden. So you are not instructing your map with a logic like if the entire values of those objects are same, like Hashcode and equals method should be overridden, then only it will identify like if all those internal values are same, then it will point to the same bucket. It should not point to different bucket. Okay, so that's why it is recommended like if you are using set or map, you should implement Hashcode and equals method with proper logic. Okay, so next comes if only Hashcode is overridden, then what will happen? So if only Hashcode is overridden, then there will be proper logic associated with that, right? So in that scenario, what will happen? So if two keys are having the same Hashcode, then what will happen? It will point to the same Hashcode. Okay, but there is no equals method overridden. So you know, right? If there is no equals method overridden, it will override the object class equals method. Okay, which will do the reference equality check. Logically, if the keys are same, which is looking to you, which looks to you that the keys are same, but map will not treat them as same. Okay, two objects can be logically same, but if equals method is not overridden, then those two keys will be put in the form of linked list in a separate node. Okay, so that thing also is very important. The keys are considered different over here because equals method are not overridden. Okay, so with the help of equals method only, it guarantees that two objects which are logically equal, those are actually equal for HashMap. So if you are not overriding equals method, those two objects will point to the same bucket, but it will create two different nodes in the form of linked list. Okay, so here you can see it is written two test objects with the same logical state might produce the same hash code, placing them in the same bucket. However, the default equals method will be used to check for key equality. Okay, this means a logically equal test object will not be considered equal by the map. Okay, so you are putting like test, then you are passing A, then you are passing same test object, then you are passing B, same thing you are passing, but you are not overridden equals method. So this test will be considered different objects. So that problem will be coming if equals method is not overridden. Next, only equals method is overridden, then what will happen? So that's fine. So what will happen in that scenario? If two keys, there is a probability, there is a high probability, let's suppose two keys are coming with the same hash code, but hash code method is not overridden, then what will happen? So those two keys can lie in two different buckets. But logically, if you see, those two keys should lie into the same bucket. Okay, it should lie to the same bucket because hash code is same, but you have not overridden any logic in the hash code, so it may lie in different buckets. So there is a data inconsistency over here. Okay, but you have overridden equals method. Then what will happen if you have overridden equals method? There is no logical correctness is there. It's everything got faded because hash code is not overridden, so it will point to two different buckets, and equals method is overridden. Then it may attach another node might be attached in the same node in the form of linked list, but there will be data inconsistency. It may lead to increased number of collisions. Okay, and logically equal keys will not be found because they are not sharing the same hash code. So this is the contract, right? So if two objects have the same hash code, then it doesn't guarantee that two objects are equal. But if two objects are equal, then it guarantees that it has the same hash code. Okay, so here only equals method is overridden. So here it is guaranteeing that equals is there, two objects are equal, but the hash code is not same. Okay, hash code is different because you have not overridden. So it will lie in two different buckets. Two equal objects lies in two different buckets. So there is a data inconsistency and it may lead to increased number of collisions. So that is the problem actually. Okay, so you should override both hash code as well as equals method, and you should not breach the contract of hash code and equals method. So this is a thing. So here, if you go, if only equals method is overridden, two logically equal test objects will be considered equal, but they might produce different hash code which will place them in different buckets. This can lead to poor performance in HashMap due to increased collisions. Okay, and logically equal keys will not be found. So if two keys are logically equal, but they cannot be found because they are lying in different buckets. Okay, you will not be able to find that. If I want to get the value of that particular key, you will not be able to find that because they are lying in different buckets. So there will be a lot of increased collision and data inconsistency will be happening. Okay, so this is the scenario with respect to only equals method is overridden. This is very much important. Hash code always returns 1. Okay, and equals method returns 2. Then what will happen? So let's understand this behavior through a code. Okay, so for rest, you can try it out by your own. This is very important and asked to me in the interview. So I will show you for this. Like if hash code is always returning me 1 and equals method is returning me 2, then what will happen in this scenario? So let's understand through a code. So I hope you can see my IDE now. So here you can see I have created one test class which contains ID name. I have created getter setter for that. Okay, I have overridden hash code which will always return me 1. Then I have written equals method which will always return me true. Okay, then I am having two string method overridden. Then I am creating object for test class T1, T2, T3, T4. I'm setting the ID and name for all the test class objects. Then what I'm doing, I'm creating one object for map. Okay, map test string. Here key is the test class object and value is string. Okay, I'm creating the new object for map. Then I'm putting the data one by one into the map. Okay, so first I'm putting T1 with string value A, then T2 with string value B, then T3 with string value C. Now, can you tell me here what will be the output of this if I'm printing the key and value? Just try to pause this video and try to understand and try to write it down on a notebook, like what will be the output for this if I'm trying to iterate over this map. So if you observe closely over here, you are overriding the hash code which always return me 1. You are overriding equals method which will always return me true. Then what will happen? Every time you are adding the data, first time you have added the data with put method T1 comma A. So what will happen? That T1 object will be there. So hash code will be returning me 1. So it will point to one particular bucket. Let's suppose bucket number is 1. And then this particular T1 comma A with hash code and next node address is null. That node will be stored there. Okay. So the node value will be stored over here. So let me show you here. Okay. So here if you see, so let's suppose map.put T1 comma A is coming. So what will happen? It will go here and it will store the data here with hash code value. Then it will come data as T1 and then it will come data as A and then next node address which is null. So like that data will be stored over here. But what will happen if I'm trying to put map.put T2 comma B? So here hash code is returning me 1. That means for T2 comma B, it will again point to the same bucket because hash code is returning me 1 always. So any number of time you are trying to put the data, it will always returning me the same index where you need to store it. So it will now point to first index. So if we have to store data here only, but how should the data be put? So equals method will be always returning me true. So equals method always returns me true means what? These all objects are becoming equal because equals method is checking the existing key with the current key. And equals method returns me true. That means this T2 and T1 is same. So if T2 and T1 is same, then what will happen? So T2 will be created, but it will point to the same bucket and same node. Okay. And B is there, then the value of A will be replaced over here. Okay. So now it will not be A. Now value will become B. So you know, right? If the same key is having multiple values, then the key will be mapped to the latest overwritten value. Okay. So all the past values will be gone. Now all the keys will point to same particular value. Okay, so whatever number of objects you will add as a key, like T1, T2, T3, T4, T5, T6, all objects will be considered equal over here. Okay, why? Because equals method always returns true. Hash code is returning me 1. That means it will point to the same bucket. And equals method is true. That means all objects are same. So it will not be connected in the form of linked list. Okay, or it will not create a separate node because all objects are equal. So in memory, it will point to the same node reference. It will point to the same node. And all T1, T2, T3, T4 up to Tn will point to the same node. And what will happen? These values A, B, C, D, E, F, G, H till Z, whatever thing you will put, if it goes till Z, then Z will be coming here as the value, and all these map key objects will be pointing to what? B. Okay, so if last value is C, it will now change to C. So all this T1, T2, T3 object, T1, T2, T3, T4 up to Tn. Anything if you do, it will all point to same value, which is the last value. Okay, if it is C, it is C, or if it is Z, it is Z. So like that, there is the memory allocation in map. In this scenario, when hash code returns me 1 always and equals method returns me true always. So now let's suppose I am taking another consideration here. When hash code is returning me 1 always and equals method is returning me false always, then what will happen? So when Hashcode method is returning me one always, it will point to the same bucket. No doubt, it will point to same bucket over here. Okay, and will first time T1A, so it will store data in here as T1A. But if equals method is returning me false, then what does it mean? It means T2 object, which is there in the key part, this T2 object is not equal to this T1 object. That means T2 object and T1 object are considered different. So here it's different, I can understand. But let's suppose when it is logically same, but that one will be considered as different by the HashMap. Okay, I hope you are able to understand it. Sometimes there can be a chance that those two objects are actually logically equal, but map will consider them as different because equals method is returning false for those objects. So what will happen here? T2 and B will be connected here in the form of linked list. Okay, so now it will store here as T2, the value is B, and then next node address is null. Here it will contain this node's address. Okay, so like that, all the data T3 also will be stored over here. Okay, T3 also will be stored over here. Like that, up to Tn data will be stored in the form of linked list in the node format. Okay, so like that it will work when Hashcode is returning me one always and equals method returns me false always. And the reverse scenario, when Hashcode returns me one always and equals method returns me true always, all the data, all the objects which are present in the key will be considered same. All will point to the same node, and the last overridden value will be there in the node. Okay, so all the objects will be pointing to the last overridden value, which is C, D, or Z, or anything. Okay, so this is the actual internal memory mapping implementation within map. I hope you got the clarity on this. So let's run the code now to see the output. Yeah, so here if you see the output, what I'm trying to do over here, I'm trying to print map.getKey, map.getValue. So here if you see what is printed over here, if you see with the help of arrow. So let me see over here. Yeah, you can see the arrow over here, right? The key is ID 0 name T1. That means only first key which you have set, that value is getting stored over here, and all other objects are considered same to this value. ID 0 name T1. All objects are considered same to this value. Then the value part is the last overridden value, which is C. If it is Z over here, it will be Z. Okay, last overridden value. Size of the map will be 1 because it's not creating multiple nodes. Okay, because equals method is returning me true always. And then when you are trying to get the values of T1, T2, and T4, it will print me the last overridden value, which is C. I hope you have got the concept. And the same thing if you are doing with the help of hash set, because hash set internally implements HashMap, and you have overridden Hashcode and equals method, and I'm passing this test class object here, then what will happen? It will take the first object and it will not print, or it will not set other objects, because all other objects will be considered what? It will be considered same. If all objects are considered same, then why the hell it should be added into the hash set? It will not be added into the hash set, because it's the actual property of hash set. It contains only unique element. It doesn't contain duplicate elements. Okay, so if you are adding the same elements again and again, so if two objects are same or equal, it will be gone. Only unique elements will be present. So you can see the hash set is having ID 0 name T1, which is the actual value of the hash map. So now you understood how hash set internally implements hash map. So this is the way it internally implements. Okay, so if you are trying to add the value over here, it will be added as a key of the hash map with value as the private static final value, which is present. That means data is present over there. Okay, so it's a constant value. So I hope you got the clarity on this. So now let me share the main screen. So I hope you got this clarity on this. It will replace the existing key value pair. Okay, so now let's go next. If Hashcode always returns 1 and equals return false, I already told you it will be placing in the same bucket, but it will create different nodes. Even if two objects are logically equal, but still it will create two different nodes and connect it in the form of linked list, because equals method returns false. Next, Hashcode method always returns 1, but equals is not overridden. Then what will happen in this scenario? It is similar to the previous scenario. Okay, so all test objects which are having the same Hashcode, it can be placed into the same bucket, because you are doing modulus with the size. It is the Hashcode is coming same. It will point to same bucket. It's fine. but equals method is not overridden, then what will happen? It will override the object class equals method. When it will override object class equals method, it will do reference equality check, meaning each object is considered unique in spite of the fact that it can be logically equal, but it will be considered different with respect to equals implementation because it's taking the default object class implementation, equals method implementation. So if two objects are logically equal, still it will be added in the form of nodes in the linked list. Okay. So I hope you got the idea on this. So it will lead to poor performance because all objects are storing in the same bucket. So hash collision. So it's a worst case time complexity will be there. So it will be around O of log n after Java 8. Let's see ahead. So if hashcode not overridden and equals method returns true, then what will happen in this scenario? Hashcode is not overridden, then what will happen? If there are multiple keys that are having logically same hashcode, that is same index value, still it will point to different buckets because hashcode method is not overridden. But equals method returns me true. That this it will check the key part, equals method is returning me true. So even if those objects are not equal, but still they will be considered equal. Okay. So since equals method always returns true, this can leads to data inconsistency. Okay. So logically all keys are considered equal. Whatever keys are there, all will be considered same. All will be considered equal. Okay. And then they will be stored in different buckets. Why different buckets? Because hash code is not overridden. So if two keys can have same hash code logically, but it will be stored in different buckets. And if they are equal, so even in spite of the fact those objects are equal, still it will be storing in two different buckets. So it creates data inconsistency, right? Whenever you will be trying to fetch the value for that key, you will not get it because those are present in different buckets. Okay, so it will give unpredictable behavior and it will lead to potential loss of your values. Okay, it will give potential issues in receiving the correct value. So this is the thing which I wanted to explain you. And last is hash code not overridden and equals method returns me false. So if hash code is not overridden, then it will, though two keys can have same hash code logically, but it will point to different buckets and equals method returns me false. Then what will happen? The test class object will have a separate key value pair. Okay, and it will be stored in the form of linked list. Okay, so here if you see, it is, wait 1 second. So here if you see, it will be written over here. The default hash code method will produce different hash code for different test object, placing them in different buckets. So it may be chance that two objects can have same hash code, but it will be putting in this different buckets because hash code is not overridden. And since equals method always returns false, that means each test object will be considered a unique key. Okay, so there can be a chance that two objects are equal because that particular object is logically already there in the hash map, but you are trying to put the same object again and again into the hash map, but equals method returns me false, so it will consider those objects as different and unique objects. So it will be connected in the form of linked list into a proper node after node after node. Okay, so the HashMap will work similar to when neither method is overridden, storing each test object as a separate key value pair regardless of their logical equality. So this is very important. They can be logically equal. Two objects can be logically equal. Employee ID 101, salary 20,000, name Dave. Employee 101, salary 20,000, name Dave. Two employee objects same, but they are considered different and unique, and they are connected in the form of nodes or in different buckets. Okay, because has equals method returns me false. So this clarity should be very much clear. If something is overridden, then what's happening? If equals method not overridden, then what's happening? If both are overridden, then what's happening? Both are not overridden, then what's happening? This should be crystal clear now. We hope you got a clarity. If you have any doubt you are facing, then comment it down below. I will be helping you out to understand your problem and solving all your doubts. Okay. So next question that might come is rehashing. So there can be a chance of two things. Hash collision you already understood. Then comes the rehashing part. So rehashing, when it works, so when the size of the hash map reaches to its threshold value, there is a particular load factor. Okay, so 16 is the size of the hash map and load factor is 75%. So if it crosses that threshold value of the load factor, then 16 multiplied by 75% is coming as 12. That means as soon as the number of key value pairs or the bucket size increases to 12 with the proper data, as soon as it crosses 12, the size of the hash map 13, let's suppose it's there, then the size will be increased by 0.75. Okay, so it will be doubled in size. So 12, 15 is there, 0 to 15, 16 size is there, it will become 30. Okay, so depending upon load factor, how much it is filled up, it will be doubling its size after that point. So this is the rehashing. And during rehashing, all the nodes that were previously pointing to a certain bucket, it will point to a different bucket now. Okay, so that will actually reduce the time complexity, because let's suppose the data gets considered in the form of nodes in the linked list. Okay, and that's crossed. It was nearly close to cross that threshold value, but it didn't able to cross that. It is having at last index 8. So after crossing 8, it will get converted to red black tree or binary tree, and it is at the last index 8. Then during rehashing, there can be a chance that those 8 nodes gone and gets reduced to 2 or 3 just. Okay, so it will reduce the time complexity by a higher margin. So that increases the performance a lot. So rehashing is very much important. So as soon as it crosses the load factor, the size of the hash map increases, and then all the nodes get shuffled up and it will go to a separate buckets based upon the hash code and equals contract calculation. I hope you got the clarity on this rehashing. Yeah, so it's the end of the thing. So I hope you got the clarity on this, how each and everything works. So these things are very much important, especially this one, when hash code always returns 1 and equals returns 2, and hash code always returns 1 and equals return false. Try to practice these questions as much as possible, because these are very much important from interview perspective. Okay, so I hope I've covered almost all kind of questions that are asked to me in the hash with respect to HashMap. So if you have any doubt, you can comment it down below. I will be happy to help you guys. So I hope you got the clarity and got the understanding, and I was able to explain you well. So it's Devjit Roy signing off. Bye bye. If you like my video, please like, share, and subscribe so that I will get a motivation to create these type of videos again and again. Thank you so much.